All right, so you've done it. You ran Cargo New, you slapped together a little Hello World in Axum, and hey, it works. But now you're just kind of staring at the screen, right? Thinking, okay, what's actually next? How do I take this little toy project and turn it into a real, a dev-ready web service? Something with proper config, a database connection, a solid structure? Well, that's exactly what we're going to break down right now.
So here's how we're going to tackle this. First, we'll look at what's missing from that basic demo. Then, and this is a big one, we're going to uncover the core Rust philosophy of composition. It's the thing that explains that whole do-it-yourself vibe. After that, we'll get practical with a dev-ready blueprint, decode all those dependencies you always see, and finally, I'll show you the real idiomatic way to kickstart your projects.
Okay, let's dive right in. Section 1, Beyond the Basic Demo. We're talking about the huge gap between that little proof of concept and a service that you and your team can actually build and maintain for the long haul.
And really, this is the heart of the problem, isn't it? That Cargo New command, it's a great start for sure, but it just gives you a blank canvas. To build a real-world service, you don't just need a canvas, you need a fully equipped workshop. And right now, that workshop is kind of empty.
I mean, just look at the difference here. On the left, that's your typical demo project, right? Everything is just crammed into main.rs, maybe you have a single route. But on the right, that's our goal. That's a dev-ready project. We're talking about real configuration, proper logging, a database pool, graceful shutdown, and most importantly, code that's actually structured and easy to navigate. It's a world of difference.
So that leads to a pretty big question, which brings us right into Section 2, Composition over Frameworks. We're about to get to the heart of why Rust backend development feels the way it does. And trust me, it all comes down to a really important core philosophy.
Yeah, if you're coming from something like Next.js or FastAPI, this is probably the question screaming in your head, right? Why isn't there a magic create Axum app command? Just one command to get a fully scaffolded project. It feels like something's missing. But here's the kicker. It's not a missing feature. It's a very, very intentional design choice.
And the answer is this core philosophy, composition over batteries included. So instead of getting a giant, opinionated framework that makes all the decisions for you, which database, which logger, which config library to use, the Rust ecosystem hands you a box of amazing, high-quality Lego bricks. Each brick does one thing and does it incredibly well. You are the architect. You get to pick and choose, assembling the exact service you need with nothing you don't.
And this really lays out the trade-off perfectly. With a batteries-included framework like Next.js, you get lightning-fast setup speed, which is awesome. But with Axum's compositional approach, you're trading that initial convenience for something else. Maximum flexibility and total control over your architecture. Yeah, the learning curve is a bit steeper at the start, but the power, the performance, and the control you gain in the long run, it's just on another level.
Okay, so we get the philosophy. Now let's get practical. Section 3 is the dev-ready blueprint. This is a solid, reusable structure that you can use for pretty much any Axum service you're going to build.
All right, think of this as your project's treasure map. The number one, most important rule, get everything out of main.rs. Seriously, by creating separate files and modules for things like your configuration, your database logic, your app state, and your handlers, you're building a service that's actually easy to understand and maintain when it starts to get bigger. Let's do a quick flyby of what each part does. Config.rs, that's where you load all your settings and secrets. db.rs is all about setting up and managing your database connection pool. State.rs defines the shared application state that all your handlers can access, like that database pool we just mentioned. App.rs is where you actually build your router and define all your routes. The handlers directory is where the real work happens, the logic for each endpoint. And what's left for main.rs? It just becomes this beautiful, clean entry point that wires everything together and starts the server. Simple.
All right, moving on to Section 4, decoding the dependencies. You know when you start a new project and you add a whole bunch of crates to your cargo.toml? Let's actually break down what those key building blocks are and what they do for us.
First up, of course, is the star of the show, Axum itself. This is our web framework. It's the whole HTTP layer. It's responsible for taking incoming requests, routing them to the right handler, managing responses, dealing with middleware, the whole shebang. If you're coming from Node.js, think of it kind of like Express. Next, we have Tokio. This is absolutely crucial. Think of Tokio as the powerful engine under the hood of our server. See, Axum is an async framework, and Tokio is the async runtime that makes it all go.
It's what lets our server handle tons of connections at the same time without breaking a sweat. And let's be clear, this isn't optional. It's the foundation everything is built on.
Now, what about handling data, like JSON? That's where CertA and CertA JSON come in. This pair is like a Rust superpower. Seriously. CertA is this incredible engine that can convert your Rust structs into, well, almost any data format. And CertA JSON is the specific plugin for JSON. This is how you're going to effortlessly take JSON from a request body and turn it into a struct, and vice versa.
And for talking to our database, we've got SQX. Now, listen up, because this is super important. SQX is not an ORM. It's not trying to hide SQL from you. Instead, it's a toolkit that lets you write actual, honest-to-goodness SQL, but, and this is the magic part, it gets checked by the Rust compiler at compile time against your real database schema. It's like having type safety for your database queries. It's amazing.
And when you add SQLX, you see those weird dash features flags? That is a perfect example of Rust's modularity. You're telling it exactly what you need. The runtime Tokyo flag tells SQLX to play nice with our Tokyo engine. Postgres pulls in the specific driver for Postgres. And macros, that unlocks the killer feature, those compile time checked queries. You only compile in what you're actually going to use, no bloat.
So, here's how it all fits together. You've got these clean, distinct layers, and each one is handled by a library that's best in class for that job. Axum for the web stuff, Tokyo is the async engine, CERD for your data, and SQLX for the database. It's just a really clean, decoupled way to build things.
Okay, let's bring this all home and answer that question from the beginning. Section 5, the real quick start. Now that we understand all the pieces and why they exist, let's look at the proper idiomatic way to start new projects so you don't have to do all this manually every time.
And here's the good news. You are absolutely not expected to do all of this by hand every single time. That would be crazy. But instead of those rigid, all-or-nothing command line tools, the Rust ecosystem has a different preference, a much more flexible approach using project templates.
And this is what that workflow actually looks like. It's super simple. You install a tool called Cargo Generate. Then you find a template you like on GitHub, there are community ones, or even better, you can make your own. And you run one command to generate a new project from that template. You get all the speed of a CLI, but with the total flexibility to customize it however you want. It's the best of both worlds.
And this really just sums it all up, doesn't it? That feeling of it being a little harder at the start, that's not an accident. It's a deliberate trade-off. Rust kind of forces you to think about your architecture and make good decisions up front, and that initial effort pays off massively later on in terms of control, performance, and how well your project can scale. And so that leaves us with this one last question for you to think about. Now that you've seen the why and the how, is that little bit of upfront effort worth the incredible control and performance you get in the end? For your next big project, what do you think? For a lot of applications out there, I think the answer is a huge yes. Thanks so much for tuning in.